All right, we were on this slide. Let's go ahead and jump over to a couple of different diagrams. These are important to at least start looking at because we are going to dissect each of these again and again. You're going to see all of them as we move on to our next topic before we come back to circuits again. So up there, it's another D latch. Instead of C, they called it G. You might see that one day. Or you can just have a box where you have D and G and Q dot, or you can have G stand for C. It doesn't matter, it works. You could represent it as a little truth table. Hey, look, we have some timing diagrams with G. And then here we have, does anyone know what this is that hasn't taken this course before? And has not taken this course before.
It looks familiar, but I don't know why.
So this is going to be a K-map. And well, I'll just say we're going to get to that later. How about that? It becomes very useful. But what's important is that Q next is equal to G naught Q or G and D. But we'll get to what that means after we get through flip-flops. And D-latch operation with the timing graph, notice that it takes some time for D to propagate down to Q. And there it is again. We could calculate out the propagation delay if we needed to. We're not going to go too much into this, but I just wanted to show you that the delay can be measured. Okay, sequential circuit has memory. It may correspond to differently to the same inputs depending on your current state. An example of that was your SR latch. Your inputs may be 0, 0, but at a different time, due to the state of the SR latch, it may put a different output. Memories can create circuits with that feedback from these latches. Latches are the simplest memory units and are not usually what you use for memory. They can be, but we're going to go into what is used, which is called a flip-flop. Flip-flop. All right. Oh, yes. So we've only talked about 1 bit. If we wanted to make a byte, which is 8 bits, what would we do?
So far the logical thing would be like just 8 circuits.
So
8
8 latches,
yeah,
right.
latches.
What would be the gate delay of setting and resetting those 8 latches?
Like what?
Depends on which latch you use.
Yeah, it depends on the latch.
To set the D latch. This is really the real question here is how much parallelism can you utilize with 8 D latches? Can they all run perfectly in parallel, or do they have to be sequential?
Are they all storing the same data?
No. So you're making an 8 byte, so each latch can hold a different value, either 0 or 1. So you may have, can y'all see that?
No, barely.
But do we have yellow? I bet you yellow will look at it. I like to use green. Actually, I'm sorry. We're doing D latches. D, C, Q, Q naught. D, C, Q, Q naught. And we draw this 2 more times. That was your key. Just when in doubt, draw the diagram. So, let me give me a number between 0 and 15 inclusively. 13. All right, so you said 13, so we need to have 8 on, we need to have the 4 on, and we need to have the 1 on, and we put a 0 here. Perfect. And then we need to have our C value. I'll put 1 right here. Okay, so we wish to set this 4-bit register to the value of 13. Okay? Because here's our representation of 13 in binary, 4 bits. Here's our control line coming up. Now it is fanning out, but we're going to ignore the cost of fan out for now. Y'all done integration, right? Yeah, so just think, plus C, whatever. You always did that plus C at the end. Yeah. We'll just call that. Here's your C. Haha. Okay. Whew. So what's the cost? What's the gate delay here?
We're still talking about D latches?
Yes, these are D latches. I put a D right here.
Yeah.
There's 4. Are they in parallel?
Yeah, they're running in parallel.
So
Whatever the cost of D latch, right? Which was 3.
4. So D latch was 4.
Oh yeah. So wouldn't it just be 4? Since
Yeah,
they're
it's
all
just going to be
parallel?
4. So you can make this thing really, really wide. The latch is running parallel, so that is just 4. Now it'll probably take more than 4 because this fan out has a cost. But for our purposes, we're just going to call it 4 to make our lives easy. Or in other words, 4 plus fan out might be a simpler way to do it.
Does it just mean that they all are controlled by the same control mechanism?
Yeah.
Okay.
Because remember I told you about the that output circuit, or I'm sorry, output, the buffer, and that was in order to increase the voltage. And you need those in order to do the fan out, and those were 2 NANDs next to each other. So that would add a gate delay of 2 if you had to do fan out. But we're going to assume no fan out, or just call it fan out. And so it's 4 plus whatever fan out is.
So the idea is as many bits as you want, you just add up.
They're all going to be 4. It's
Okay.
just going to be, like, if you have 32 of these, what's it going to be? 4.
No, I didn't mean
plus
the
fan out.
delay. I
Right.
just meant like you put a D latch for each bit that you want, right?
Mhm.
Okay.
Do a D latch for every bit. That is what they do, except we're going to use flip flops instead of D latches.
Flip-flops are cool.